Avicena is a very ambitious company. We're trying to solve probably the hardest problem in computing, which is how do you move data? This problem has become acute in recent years because of new architectures like machine learning and AI that need massive number of connections between processes and also between processors and memory. Moore's law has done a lot for computing over the past few decades in making the transistors smaller and faster, but what it hasn't done is really made the movement of data easier. You still have to use copper wires that have electrical resistance and capacitance. When you move to photonics, you can overcome that bottleneck and have massive parallel flow of data between chips at very low energy. For decades, people have dreamt of doing that I/O optically, but there hasn't been a good way of integrating lasers with silicon, having a good light source and a good receiver on silicon chips. And what Avicena has done is taken the humble LED and made it a lot faster.
This is our demonstration. It's built on an advanced ASIC on a 16nm node. We have two arrays. The first is a 331 transmit array. It comprises 331 LEDs with a combined data rate of almost 1 terabit per second in a space of only 1 millimeter squared. After the data travels through the fiber bundle, it's focused onto an array of 331 photodetectors.
Avicena has developed these micro-LED arrays up with fiber cables with multiple fibers, detector arrays which serve the purpose of detecting the signals in the multiple channels. Before this, I think no one would have thought that LEDs could function at the speeds that Avicena has demonstrated. And I think finally, after many years of false starts in optical interconnects, I see the potential for real success.
Our technology requires a bunch of different disciplines. We have chip design, high-speed LED design, optical packaging, coupling fiber optic bundles to our LEDs and photodetectors, and also more conventional advanced electrical packaging technology. So all of them are well-established fields, and we're bringing them all together to create this very innovative product.
From the management side, we have this culture that is really open. Everybody in the company knows where we're going, what are the goals, what's their part in this path. I think that is something remarkable, to all be working as a team, but at the same time feel responsible and ownership for your own job.
We're a really energetic, diverse workforce. We're really engineering focused, and we all have a passion for technology.
I think what we're really doing here has the potential to change the world, and just being a part of that is something that's very exhilarating.
It's, I think, the world's lowest energy and densest optical transceiver chip ever made. It does a terabit per second at about a picojoule per bit. And this demonstration's created some waves in the industry. We have the biggest companies in our space coming to us, asking us to work with them to develop custom products or help us define specifications. Usually when you're a startup, you have to work your way up to those tier 1 companies. But in this case, because our technology is so compelling, they're coming to us. And that's very, very exciting.